In the previous section, we took a look at some really basic sorts of aspects of functions. So we looked at how to evaluate a function, to be able to determine the x-intercept, the y-intercepts, some values of a function, domain and range. In this lesson, what we're going to do is we're going to take a look and look a little bit more about functions. And specifically, we're going to be taking a look at symmetry and the idea if a function is either even or odd. We're going to take a look at determining whether increasing, decreasing, or constant. We're going to take a look at these things called maxima and minima. We're going to take a look at symmetry with respect to axis or origin. And then we're finally going to go through and take a look at these things called piecewise functions. And then the last thing that we're going to take a look at, one of the more difficult algebraic sorts of things that we're going to look at, is we're going to look at this thing called the difference quotient in this section. So as you can see, this is a pretty dense section. So if there's more videos in this section than those previous ones, it's just because that there's a lot more material to cover in this one. So let's start by talking about what the idea of an even function and an odd function is. An even function basically means that if we plug in negative x, we get the exact same function that we started with. A function is odd if we plug in negative x and we get the opposite of the function that we started with. Now, even functions and odd functions exhibit symmetry. And symmetry basically means that if we were to cut the function in half, either vertically or horizontally or some nature like that, that we would have the exact same thing on both sides. So for instance, I want you to take a note of this function, f of x equals x to the fourth minus x squared. And that is an even function. And the reason it's even is because notice right here, we have the exact same function or the exact same value, excuse me, as we go along the y-axis, right? So if I look at this point right here, it's equidistant from the y-axis. And every single point that I circle, they are all equidistant from the y-axis no matter what, all right? So that's what it means to be an even function. It means that we have symmetry about the y-axis, all right? So if a function is even, it's going to have symmetry about the y-axis. And if a function's odd, that means it has symmetry about the origin, which basically means in catty-quarter quadrants, we have the exact same points. So notice we have the point 1, 2 in quadrant 1. In quadrant 3, we have the opposite. Okay, so remember, if we plug in negative x, we should get the opposite. And so notice right here, we have this point that's like close to 1, 1. And then over here, we have another point that's close to negative 1, negative 1. And we could do this exact same thing. And so that's what symmetry means about the origin. It means that if we have catty corner either from left to right or from right to left, that means that we have symmetry about the origin. So that's what symmetry means. All right. So now what we're going to do is we're just going to plug in negative x, and we're going to determine if a function is even or odd or neither, because not every function has symmetry exhibited. So let's take a look at some examples of this. So without graphing, we're going to determine if a function is even, odd, or neither, and then we're going to describe the symmetry of the function. So the first one we have is f of x equals x squared minus 2. The test for symmetry of a function is to plug in negative x. And so that means we're going to get negative x squared minus 2. And we know that anytime we square a function or square a negative number, it's going to take and to get rid of that negative. Right? Now, I want you to notice that when we simplify it, it is exactly the same. Okay? So what that means is that we have an even function. And also what it means is that it's going to be symmetric about the y-axis. Okay. So that's all we have to do with this. We just have to simplify when we substitute negative x back in. And of course, we can always check this by graphing. And I know the problem says without graphing, and we certainly did that. But if we were to go through and just plug in y equals, remember, f of x and y are the same thing, x squared minus 2, then I want you to notice that right here, this point and this point are the exact same. Right here, we have negative 2, 0, and then we have, negative 2, 2, and then we have 2, 2. So these points are going to be exactly the same for each of those, right? So another example of determining whether a function is going to be even, odd, or neither, we have this function x to the fifth plus x cubed plus x. And what we're going to do is we're going to plug in a negative x. And so that's going to be negative x to the fifth plus negative x cubed plus negative x. Now, anytime that we raise a negative number to an odd power, it's going to stay negative. And so this is going to work out to be negative x to the fifth plus a negative x cubed plus a negative x. Or another way to write that is if we were to factor a negative from that, because we've seen that before where we factor a negative, that would become x to the fifth plus x cubed plus x. And that's exactly the opposite of what we started with. Right? And so what that means is that this is going to be an odd function, and that means that it has symmetry about the origin. So symmetry about our origin. All right, and just because it bothers me, I know that M doesn't have 3 humps in it. All right. So at this point, what we're going to do is take a look at a couple more functions. All right. So we have this h at x is absolute value of x plus 1. So h at negative x is going to be equal to the opposite of the absolute value of x plus 1. And we probably recall in the previous section that anytime we take the opposite absolute value of a negative number, it's going to become positive. So another way to write this is absolute x plus 1. And algebraically, what's going on behind that, just to make sure everybody understands, is that that's the absolute value of negative 1 times x, which is the same as negative 1 absolute times x absolute. Absolute value of negative 1 is positive 1, so we get 1 absolute x, which is just going to be absolute x. So just verifying for you, if you're the type of person that really cares fundamentally about how that happens. Regardless, what we notice is that these are the same, which means that we have an even function. And anytime we have an even function, it is symmetric about the y-axis. And again, we can graph these, okay? So I'm going to graph the previous and this one just to verify. So we remember that we had x to the fifth plus x cubed plus x, right? And we can see that there's points that are going to be basically catty corner from one another. So we have this point, and then we have this point. They're basically the same point except in opposing quadrants. And that goes all the way up and down with this. And of course, we had our absolute value of x plus 1. Right? And clearly that demonstrates, like right here, we can see that these points are equidistant from one another. So once again, we're demonstrating symmetry about the y-axis in this example. All right, now, like I said, not every function exhibits symmetry. So here's a last example. And j at negative x is going to be negative x to the fifth plus negative x cubed plus 1. All right. Now, like we said, anytime that we raise anything to a negative power or to an odd power, it's going to keep the sign that it has. And if a negative to the fifth power, it's going to stay negative. So we get negative x to the fifth plus negative x cubed plus 1. And if we were to factor a negative from this, because clearly not the exact same as what we started with, but if I factored a negative, that would be x to the fifth plus x cubed, but then the sign would change. All right. So what that would mean is that these are neither even nor odd. Okay. So it's neither, and which implies that there is no symmetry. Okay. All right. So that's how we can look at a function and determine if there's any symmetry to that function. So in the next videos, what we're going to do is we're going to go through and take a look a little bit more about functions with respect to symmetry. And we're also going to take a little bit more of a look at even and odd, and we're going to take a look at increasing and decreasing in subsequent videos with respect to functions.